everybody, this is Mrs. Bright. I am here to review with you the second part of protein synthesis called translation. Before we get into our diagram, I just wanted to revisit the cookie synthesis analogy that we used a couple of days ago. So if you recall, the original cookie recipe is one that my grandmother stores in her house in Florida, and if I want to make a copy, or if I want to make this recipe, I have to get a copy from her. She's keeping that recipe nice and safe for me. So once I do get the copy, I'm going to use those instructions to help me build my final product, which is the cookie. So this is very similar to the process of protein synthesis in the fact that our DNA, which is like our recipe, is housed in a safe place, the nucleus. And since we can't take it out of the nucleus, we have to first write it down into a copy, or what we refer to as messenger RNA. That process is called transcription, and we went over that last week. Now we're going to move on to the secondary process, which is called translation. And if you think about that word, if you translate something, you're taking it from one language to another. So in this case, our mRNA, which is a nucleic acid language, is going to be translated into a protein language, which is the language of amino acids. So thinking about our analogy again, the recipe being the mRNA, that recipe, I can then use those instructions to help me put together my final product. And in this case, my final product is going to be the protein. So if we go back to our note sheet, and I encourage you to pull yours out from last week and make sure that you understand this diagram before you take your assessment this week. To review, we know that this is happening in the nucleus. It's transcription, the first step, where we open up our DNA and then RNA polymerase goes in and pairs up the DNA nucleotides to RNA nucleotides. So A will be paired with U and G will be paired with C. Once that mRNA is made, it's going to travel outside of the nucleus and it's going to move out into the cytoplasm. Now that's where we're going to pick up with our new step. So this one right here is the mRNA. It's the same piece that was made over here in the nucleus. And I'm just going to put that little note in here, made in the nucleus. And it's been out here in the cytoplasm, so the very first thing that needs to happen is that the organelle, the ribosome, has to attach to it. So right here with number 2, we're seeing the ribosome, and then if you notice there's a second one right here. So those ribosomes are responsible for reading the code in the mRNA and making sense of it, translating it. So what the ribosome does is it reads it 3 bases at a time. So right here we see U, U, U. Those are 3 nitrogen bases. And those 3 nitrogen bases have a name. We call that the codon. A little way to help us remember it, codon sounds like code on. So this is where the code is found. It's on the mRNA. So the ribosome is going to read it 3 letters at a time. So first it's reading U, U, U. Now it needs to put together this protein, so it's going to need some amino acids. Well, what's responsible for bringing the amino acids to the ribosome is the tRNA molecule. That T right there stands for transfer. And I like to think of the tRNA, another little way to remember it, it kind of looks like a T. So the tRNA is going to carry with it an amino acid. And each amino acid is specific to the tRNA that is carrying it. How will this tRNA know that it is correctly paired up and capable of leaving its amino acid behind? Well, that comes from these 3 bases right here, which we call the anticodon. So think anti, opposite of codon. So if my codon right here is GGC, then the anticodon to GGC would be CCG. They're opposite of one another, so they can attract. Now, once the tRNA is in the correct codon-anticodon pairing, it will be able to leave behind its amino acid. So this amino acid will bond right here with this growing chain, and ultimately, when we're going through the whole mRNA sequence, we'll have a long chain of amino acids at the end. Those amino acids then will break off and they will fold to create our protein. So this step right here is referred to as translation. Hope that was helpful. Have a